Good morning, everyone. Me and my groupmates will present and explain to you the significance and interpretation of Second Law of Thermodynamics. We hope that even in this kind of learning, you will still listen and learn something today.
Hi, my name is Tristan Arpatastadas, and today I will be discussing the second law of thermodynamics. The second law of thermodynamics states that the entropy of the universe increases in spontaneous process and remains unchanged in the equilibrium process. The spontaneous process occurs on its own, while the equilibrium process change doesn't occur at all. The second law of thermodynamics says that every process involves a cycle and the entropy of the system will either stay the same or increase. Also, even when the cyclic process is changeable, then the entropy will not change. Moreover, when the process is unalterable, then the entropy will increase. In spontaneous process is a physical change or chemical change that occur by itself. This process occurs without requiring an outside force and continue until equilibrium is reached. Like this cup of coffee and sugar. The sugar is the solvent and the cup of coffee is the solute. When you drop the sugar in the coffee, it will dissolve on its own, and this is a perfect example of spontaneous process because the solvent and the solvent mix on its own without any kind of help, and it will change until the equilibrium is reached. And for example, other examples is rusting. When you leave a metal for too long and until it gets old, it will rust because it has a chemical change that occurs on itself. And for the rusting, it doesn't need a solute or a solvent for a chemical change occur on its outer and physical state. In a chemical reaction, change in reaction equals enthalpy of products minus enthalpy of reactants. If it is exothermic, then the change of enthalpy of the reaction equals to negative. To get a negative, enthalpy of change in enthalpy of the reaction, the enthalpy of the product must be lower than the enthalpy of the reactants. For example, the combustion of methane, the given is that CH sub 4 plus 2O sub 2 and 6CO sub 2 plus 2H sub 2O. And for this, the standard entropy of the CH sub 4 is negative 393.5 plus, and the standard of the standard of the and the standard enthalpy for oxygen is negative 285, and the standard enthalpy for CO2 is negative 74.8, and it's also for H2O is 0. And if you add all of those up, and if you add all of those up, it will result to 8. The answer, change in enthalpy equals minus 890.4 joules per molecule. And the solid to liquid phase transition of water goes with the same process like the combustion of methane. And entropy and the symbol of the entropy is S, is the thermodynamic quantity that is measure of how spread out or dispersed the energy of the system is. Among the different possible ways that system can contain energy is the quantity that is generally used to describe the course of the process, that is whether it is a spontaneous process and has a probability of occurring in a defined direction, or a non-spontaneous process and will not proceed in any defined direction, but in refined direction. The SI unit of enthalpy is joules per Kelvin. You can write it like J/K, And and for the entropy, the higher the energy, the higher the entropy will be. And entropy occurs like this. The most processes are accompanied by entropy change. The following processes are that led to an increase in entropy of the system. Like process of melting solid to liquid, which the solid if the solid has the lower entropy and liquid has the higher entropy the high because the more the molecules are spread out, the higher the entropy will be. So if the solid has the lower energy and the lower enthalpy than the gas. Like vaporization, high liquid has the higher entropy than the vapor, and dissolving solute has lower entropy than the solution. The spreading out of more concentrated molecules and the spreading out of more concentrated energy are changes from the order to more random. The changes that occur are the ones that lead to increasing randomness of the universe. Entropy is sometimes referred as the measure of randomness and disorder. That's right. In short, the meaning of entropy is the disorder and heat transfer effect. Because and the higher the entropy, the more spontaneous it is, and the entropy is the non-spontaneous one. So direction of the heat flow to the left, like this. At, at high enough temperature, the spontaneous change is from solid, liquid, gas. Gas is more random than the liquid, and the liquid is more random than the solid. There is an increase in entropy of the system by going from solid to liquid. Like I said, the higher the entropy, the more spread out the molecules will be. Like solid has compact molecules than the liquid, so it has a lower entropy and lower energy. The second law of thermodynamics deals with entropy. It tells whether a process or chemical reaction can occur. The connection between the entropy and the spontaneity of the process is expressed by the second law of thermodynamics. And it states that the entropy of the universe increases in spontaneous process and remains unchanged in the equilibrium process. Because the universe is made up of the system and the surroundings, the entropy change in entropy universe for any process is the sum of the entropy changes in the system and the surroundings change of the universe of surroundings. And this is the formula. Change in entropy of the universe equals change in entropy of the system plus change in entropy of the surroundings is greater than zero, then the process is spontaneous. And if the change in entropy of the universe equals change in entropy of the system plus change in the entropy of the surrounding is equals to zero, then the process tends to not occur and equilibrium is attained. Change in entropy of the universe equals change in the entropy of the system plus change in entropy of the surrounding is less than zero, then the reverse process occurs spontaneously. And how is entropy change determined? What are the data needed for the calculation? So this is the data for the calculation of the entropy change. Suppose that the system is represented by the following reaction. This is the form, you'll see the formula here in the presented PowerPoint. As in the case for the enthalpy of reaction and the standard entropy of the reaction, change in entropy Rx and is given by the difference in standard entropies between the products and the reactants. Change in entropy equals the summation of N entropy of the products minus summation of M and entropy of the reactants where m and n are the stoichiometric coefficients of the reaction. Change in entropy of Rxn equals the summation of C entropy of C and plus D entropy D minus A of the entropy of A plus the B of entropy of B. The standard entropy values of compounds have been measured for in joules to molecules. To calculate the change in entropy, which is Rx and which is in the change in the system, change in of the S of the system, the values may be found in the thermodynamic table, and the thermodynamic tables are the absolute entropy of the given substance of any given substance at 25 C and 1 atmosphere. This is the thermodynamic table and substance and joules to molecules from gases to liquids and solids will be there. This is the primary example of the thermodynamic table. So that's it. Thank you.
So for our next topic will be a sample problem on calculating entropy. From the standard entropy values in the thermodynamic data table, calculate the change in entropy for the following reaction. Hydrogen plus iodine yields to 2 moles of hydriodic acid. So step 1, write the standard entropy below each formula. So yung thermodynamic data table, dun nakikita yung mga standard entropy dun sa bawat element or dun sa compound. So dito given na yung standard entropy dun sa bawat element. So for hydrogen will be 130.6 um joules per Kelvin mole. Then iodine 116.7 joules per Kelvin mole. Sa 2 moles of hydriodic acid will be 206.3 joules per Kelvin. So the next step will be using the equation for the standard entropy of reaction. We will calculate the reaction. So yung magiging formula natin is change in entropy equals summation of n or summation of moles, then entropy of the product minus summation of m or moles, then entropy of the reactants. So, palagi nating tatandaan na babaliktad yung yung reaction or yung sa chemical equation, mauuna lagi yung product na i-minus kesa dun sa reactants. So, dito, nagkaroon ng 2 dito sa parenthesis dahil 2 moles of hydriodic acid. So, yung summation niya or yung summation of M is equals to dun sa moles. So, meron dun 2. So, nagkaroon dun ng 2 para dun sa hydriodic acid. Then, 1 naman dahil 1 mole of hydrogen at 1 mole din naman siya ng iodine. So step 3, substitute the entropy values. From the given thermodynamic data table, the standard entropy, we will substitute the values. So for hydriodic acid will be 206.3, then for hydrogen 130.6, then iodine 116.7. Bago natin siya ipag-minus, pagpa-plusin muna yung sa reactants na hydrogen at iodine. So 247.3. Then, minus lang natin dun sa nakuha natin sa hydriodic acid na 412.6. So, the answer will be the change in entropy for the reaction of hydrogen plus iodine yields to 2 moles of hydriodic acid will be positive 165.3 joules per Kelvin. So, ibig sabihin positive, mas mataas yung chance ng disorder dun sa kanyang reaction. So, what general rules apply to predicting whether an entropy change is negative or positive? So, here's the general rules for predicting entropy change of the system. Number 1, if the reaction produces more gas molecules than it consumes, the change in entropy is positive. So, kapag yung sagot natin ay positive, ibig sabihin mas maraming gas yung na-produce ng molecules kesa dun sa na-absorb niya. Kapag naman dito naman sa number 2, if the total number of gas molecules diminishes, the change in entropy is negative. Kapag naman negative yung sagot dun sa change in entropy, ibig sabihin mas kaunti lang yung gas molecules na na-produce niya. And if there is no net change in the total number of gas molecules, the change in entropy may be positive or negative, but will be relatively small numerically. Kapag naman walang nangyaring change or positive, either positive or negative lang yung magiging sagot, then walang nangyaring disorder dun sa isang reaction. So that's the general rules for predicting whether an entropy change is negative or positive. Kapag mas mataas ba yung disorder or mas mababa yung disorder. So, predicting the spontaneity of a process based on entropy. For constant pressure process, the heat change is equal to the enthalpy change of the system. Then the change in entropy of the surrounding is proportional to the enthalpy change of the system. So the minus sign is used because if the process is exothermic, the enthalpy change of the system is negative and the change in entropy of the surrounding is positive quantity, indicating an increase in entropy. So kapag exothermic meaning the process that release energy. So siya yung nagpalabas yung pag niya ng energy. So kapag exothermic, yung enthalpy change ng system ay negative at yung change in entropy naman ng surrounding ay positive quantity. And kapag positive yung change in entropy, ibig sabihin, mas mataas yung disorder or mas may increase dun sa entropy. Dun yan sa exothermic reaction. Enthalpy change or yung itong sign na may triangle na H tsaka system, ibig sabihin ay negative. Tapos kapag yung change in entropy of the surrounding ay positive, exothermic yung reaction. Then for endothermic process or yung sa process naman na paloob, yung pag-absorb ng heat, then yung enthalpy change of the system is positive and negative sign ensures that the entropy of the surrounding decreases. Baliktad naman sila. Kapag endothermic process, yung enthalpy change ng system ay positive, then yung um, negative sign ng change in entropy of the surrounding ay negative. So, ibig sabihin, mas mababa yung chance ng disorder or ng entropy dun sa isang reaction. The change in entropy for given amount of heat absorbed also depends on temperature. Pero nakadepende pa rin dun sa temperature ng isang surrounding or dun sa universe dahil makaka-apekto din yun dun sa magiging sagot dun sa enthalpy change or dun sa change in entropy of the surrounding. If the temperature of the surrounding is high, the molecules are already quite energetic. Therefore, the absorption of heat of an exothermic process in the system will have relatively impact on the motion of the molecules and the resulting increase in the entropy of the surrounding will be small. So, di ba kapag naman yung temperature ng isang surrounding ay mataas, so yung mga molecules na may chance na mag-bounce or maglayo-layo sila dahil na energetic yung mga molecules. So, kapag dun sa absorption ng heat ay exothermic or yung sa palabas, ibig sabihin, yung entropy ay magiging mas mababa. Di ba kapag exothermic, kailangan ay mataas yung entropy. So, kapag yung surrounding mo ay high or mataas yung temperature ng surrounding, ibig sabihin, kahit exothermic yung process niya, yung yung entropy ng surrounding ay magiging mababa pa rin. However, if the temperature of the surrounding is low, then the addition of the same amount of heat will cause a more drastic increase in molecular motion and hence a larger increase in entropy. So kapag naman exothermic pa rin yung process tapos yung temperature ay mababa, doon naman mas magiging mataas yung entropy dahil dun sa temperature na low, so mas drastic yung increase ng molecular motion niya. Mas freely silang makakagalaw dun sa isang surrounding. So, ito yung formula para makuha natin yung spontaneity ng isang reaction or isang process base sa entropy. So, change in entropy of the surrounding is equals to negative enthalpy change of the system over temperature. So, here's a sample problem para mas lalo natin siyang maintindihan. Applying the procedure for calculating the change in entropy of the system and change in entropy of the surrounding to the synthesis of ammonia. Is the reaction spontaneous at 25 degrees Celsius? So for our given reaction is the chemical equation or balance equation of ammonia. N2 plus 3 moles of hydrogen yields to 2 moles of NH3. So here's the enthalpy change of the ammonia, negative 92.6 kilojoule per mole. So first we have to calculate the change in entropy of the surrounding. So change in entropy of the surrounding, yung formula natin kanina na negative enthalpy change of the system over temperature. So substitute lang natin yung given, then nagkaroon dito ng 1 kilojoule over 1,000 joule dahil ang SI unit ng entropy ay joules per Kelvin dapat. So we have to divide them para mawala yung kilojoule dun sa unit para matira na lang ay yung joules per Kelvin. So substitute lang natin siya, negative 92.6 times 1, then over 298 Kelvin. So naging 298 Kelvin yun dahil diba 25 degrees Celsius, we have to convert it into Kelvin, then 273 plus 25, so ang sagot ay 298. Then i-substitute lang natin siya, ang magiging sagot ay 3.11 joules per Kelvin mole. Yun yung sagot sa change in entropy of the surrounding. So next step, we have to calculate the change in entropy of the system naman. So pag change in entropy of the system, we have to look at the thermodynamic data table na given na yung standard entropy ng bawat element. For N2, 192, for 3 moles of hydrogen, 131, and NH3 will be 193. So yung ating formula para makalculate yung change in entropy of the system will be change in entropy of the system equals summation of N or yung bilang ng moles, entropy of the products minus summation of M, entropy of the reactants. So substitute lang natin muna yung mga given moles nila kung ilan ba yung moles na meron sila para hindi rin tayo malito. So next, substitute naman natin yung standard entropy na 193, 192, at 131. So, tandaan na mauuna lagi yung products kesa dun sa reactants. So, solve lang natin siya. Then, the change in entropy is equals to negative 199 joules per Kelvin mole. So, next we have to determine the spontaneity of the reaction using the change in entropy of the universe. So, ang ating formula para ma-calculate natin yung change in entropy of the universe is change in entropy of the system plus change in entropy of the surrounding. Yung nakuha nating sagot kanina ay pagpa-plus lang natin siya, negative 199 plus 311 joules per Kelvin mole. So, the answer will be 112 joules per Kelvin mole. Yun yung sagot dun sa change in entropy of the universe. Because the change in entropy of the universe is positive, we predict that the reaction is spontaneous at 25 degrees Celsius. So, ibig sabihin, positive yung naging sagot, yung reaction ay spontaneous and mas mataas yung chance ng disorder or nung entropy dun sa kanilang reaction. So, our next topic will be Gibbs free energy.
Gibbs free energy, another thermodynamic function, is used in order to express the spontaneity of a reaction more directly. This is called Gibbs free energy, or G. The use of G predicts changes that are focused in the system. So we use Gibbs energy to determine the spontaneity if ang process ba is spontaneous or non-spontaneous. So I will explain that later. Gibbs free energy is defined as G is equals to H minus Ts. I will also put emphasis on this later. All the quantities in the equation pertain to the system. T is the temperature of the system. G has the units of energy. Both H and Ts are in energy units. So H, S, and G are all state functions. So yun yung purpose ng Gibbs energy is to identify the spontaneity of a reaction more directly. Kung Spontaneous ba siya or non-spontaneous? So, the change in free energy is a convenient way to predict a change. So, yung triangle G or alpha G is read as the change in free energy. So, itong table na to, this will help us identify easily identify or matutulungan tayo nitong i-identify kung spontaneous or non-spontaneous ba siya. So, the change in the entropy of the universe, if the change of the entropy of the universe is positive, then the change in free energy is negative, and the reaction will be spontaneous. So, and if the change in entropy of the universe is zero, same lang din siya sa change of flow and that change in free energy, zero din siya. And then the reaction will not change at equilibrium. So if the change in the entropy of the universe is negative, magiging no positive or positive ang flow ang change in free energy, and it will decrease and the reaction will not be spontaneous. So, para mas madali, kapag positive ang change in entropy of the universe, negative ang change in free energy. So, kapag naman negative ang change in entropy of the universe, magiging positive naman ang change in free energy. So, ganun din sa reaction. If negative ang change in free energy, spontaneous siya. So, meaning, kaya niyang mag-change or the process will still go on even if there are no affecting factors. So, there is no factors affecting our process. And pag positive naman siya, or pag positive naman ang flow, ang free energy, the reaction is not spontaneous or hindi siya mag-work or hindi siya gagana ng walang factors na mag-a-affect. Or pag zero naman siya, zero ang change in free energy, it will just stay the same and no change at an equilibrium. Determining the spontaneity of a reaction using the change in free energy. The change in free energy or of a system for a constant temperature process is ito. Ito ang ating magiging equation. So, the change in free energy is equals to the change of enthalpy minus temperature in Kelvin times the change of entropy. In this context, free energy is the energy available to do work. If a particular reaction is a energy or exothermic, if the free energy is negative, the reaction will be spontaneous or is spontaneous unless stated otherwise that the change of enthalpy and the change of entropy and the change of free energy refer to the system at 250 Celsius. Most of our calculations are for values of change of free energy at 250 Celsius or 298 Kelvin. The summary of conditions of spontaneity and equilibrium at constant temperature and pressure in terms of the change of enthalpy, the change of free energy rather. So, ito ay katulad lang din ng table pero parang naka-word form siya. Ulitin ko na rin or I will emphasize na lang din. I will emphasize na lang din para mas maintindihan nyo or mas maintindihan natin lahat ng mas madali. So, the change in the free energy, when the change of the free energy is less than zero, the reaction is spontaneous in the forward direction. So less than zero meaning negative siya, katulad ng din nasa table kanina. So and if the change of the free energy is greater than zero, so positive, the reaction is non-spontaneous and the reaction is spontaneous to the opposite direction. So non-spontaneous siya. So and if the change in the free energy is equal to zero, the system is at equilibrium, so there is no net change. Methods to determine change in Gibbs free energy: determining the change of free energy using the change of enthalpy and the change of entropy data, calculating the change of free energy from standard free energies. So here's a sample problem. The old camera flash bulb used magnesium metal sealed in a bulb with oxygen. The reaction is this is already a balance equation. Magnesium plus 1/2 of oxygen will yield into magnesium oxide. So kung nagtataka kayo kung saan nakuha itong 32.7, 205.0, and 26.9, nakuha ito sa already given na to dun sa table ng thermodynamics data chart or data table. Kukunin niyo na lang siya and then isa-substitute niyo na lang. Tas same lang din dito sa change in enthalpy uh, change in enthalpy kilojoules per mole. Ganun lang din, kinuha lang din siya dun sa table of thermodynamics data chart or data table. Then to calculate for the change in entropy, sasubstitute lang natin yung mga data or mga values na nakuha natin from the table doon sa So substitute natin. So 1 times 26.9, which is magnesium oxide, minus 1 times 32.7, which is the value of magnesium sa table, plus 1/2 of oxygen, which is 205.0 ang equivalent. So calculate lang natin siya para makuha natin ang change in entropy. Ang makukuha nating value is negative 100.83. So magagamit natin to para makuha natin or para ma-determine natin ang change in free energy. So next, para makuha natin ang change in free energy, we need to calculate for the change in enthalpy. So to calculate the change in enthalpy, isa-substitute din natin katulad ng ginawa natin kanina. But ang gagamitin natin is itong line na ito, which is nakuha lang din to sa table. So pag sinubstitute natin siya, so 1 for magnesium oxide is the equivalent of magnesium oxide sa table is negative 601.2. So ito. Then minus 1 times 0 kasi 0 yung magnesium sa table plus 1/2, which is 0 din yung oxygen. So cancel na natin to. Ang magiging sagot natin is the change in enthalpy is equals to negative 601.2. Now that we have the change in enthalpy and entropy, we can now calculate for the change of free energy or in free energy. So again, substitute the values to get substitute natin yung change in enthalpy, which is 601.2 kilojoules minus the temperature minus the temperature, which is 298 Kelvin, times the value of the change in entropy times 1 kilojoules over 100 joules para makancel. So ito na. So ito yung magiging sagot natin. So i-calculate natin muna to, then ang magiging sagot dun is 32.3 kilojoules. Tapos plus natin siya sa negative 601.2 kilojoules. Ang magiging sagot natin, ang ating sagot, which is the change in free energy, is negative 568.9 kilojoules. So dahil negative siya, this means that the process or the answer of this sample problem is spontaneous kasi negative siya, or less than 0 yung naging answer ng ating free energy. So that's how we identify that's the process of identifying the spontaneity of a problem. That's all. Thank you.
Calculating change in free energy from standard free energies. If the data for change in free energy of formation, standard free energy of formation of the reactants and products are available, the following equation is used. Delta G degree equals summation of N delta G F degree, which is the products, minus summation of M delta G F degree, which is the reactants, where M and N are the stoichiometric coefficients in the reaction, and delta G F degrees is standard free energy of formation. And nandito, both sides, which is the products and reactants. Delta GF degrees is standard free energy of formation at 25 degrees Celsius and 1 atmosphere for 1 mole of compound formed from its elements. The delta GF degree can be used to get the change in free energy of a reaction, just like using standard heat of formation to get the change of enthalpy for reaction. Itong delta HF degree, yun yung standard heat of formation niya. Tapos, itong delta H ay yung change of enthalpy. The standard free energy, change in free energy of element in the standard state is 0. So, ito. Meron tayong sample problem of calculating in change of free energy from standard free energies. Tanong ay, will this reaction occur at 298 Kelvin? Tapos ang kanyang given ay copper plus oxygen. Ito yung kanyang products. Tapos ang reactant niya ay, magiging reaction ay cupric oxide. Tapos, then ito. The thermodynamic table to find the standard free energy of formation for Cu and for copper and oxygen are 0 since they are pure elements. Kaya 0 siya dahil ang copper at ang oxygen niya ay pure elements. Tapos dito sa magiging reactant, kaya naging negative 130 dito sa Gibbs free energy niya. Meron tayong ditong table na ito sa thermodynamic table. Hanapin natin yung cupric oxide. Ayan. Diba, ano, solid. Ito, solid. Hanapin natin sa part ng Gibbs free energy. So, ito. Ang kanyang standard free energy of formation ay negative 129.7. Kaya pag ni-round off natin, magiging negative 130. So, ito yung formula na ating gagamitin. Change in free energy equals summation of N standard free energy of formation, which is the products, minus summation of N standard free energy, which is the reactants. Ang products ay nasa left and ang reactants ang nasa right. Tapos, itong summation, it is telling us to add all of the products. Tulad, diba ito? I-add daw itong dalawa. Tapos, itong N, or itong M, yan yung nagre-refer sa ating mga moles, in our balance equation, ito yung mga nandito sa gilid. Pero dito, Cu. Diba, ito, pag ganyan, automatically, 1 yan. Yun yung mole natin. Tapos pag magko-compute ka, ang mangyayari, reactants to the left, then products to the right. Ito. Ito ang cupric oxide natin, mapapapunta dito sa left. Tapos ito, yung kanyang N na nagre-refer sa mole, 1 siya. Tapos minus summation of the products. Ito. Copper plus oxygen. Tapos ang kanyang mole ay, itong copper ay 1. Then yung oxygen ay 1.5. Then tapos ito, ilalagay na natin dito yung kinuha natin sa thermodynamic table. Ang reactant ay negative 130, tapos ang copper ay 0, at yung oxygen ay 0 dahil nga sila ay pure elements. Tapos pag kinompute mo yan, ito ang magiging sagot. Change in free energy equals negative 130 kilojoules per mole. Kaya kilojoules, ang unit ng change in free energy dito sa Gibbs free energy ay kilojoules per mole. Makikita mo rin siya dito sa table. Ito. So ito, negative change of free energy, ito yun. Negative siya. Kaya siya negative, ang ibig sabihin niyan ay, the reaction will occur but because it is very slow at room temperature. It can take years of a penny to get cupric oxide coating and turn brown. The reaction can be sped up by raising the temperature. So next is the effect of temperature effect on chemical reactions. The change of free energy can be found for different temperature values. The change of free energy equals change in enthalpy minus temperature times change in entropy. The values for delta S from S and delta H from standard heat of formation can be derived from the thermodynamic data table for both reactants and products at 25 degrees Celsius and 1 atmosphere. Enthalpy and entropy will vary with temperature, but the variation is frequently small. In the calculations, it will be assumed that there is no variation in change of enthalpy or change in entropy, but only in temperature and change of free energy. So, ito. Meron tayong sample problem. Ang given sa change of enthalpy ay positive 177 kilojoules and sa entropy naman ay positive 285 joules per Kelvin for the reaction. Tapos, itong NH4Cl ay ammonium chloride. Then, itong NH3, ammonia plus hydrogen chloride. Ito yung reactant. Ito yung product. Mga products. Then, ito. Find the change of free energy at 25 degrees Celsius and free energy at 500 degrees Celsius. E di dalawang hinahanap niya. Dito muna tayo sa 25 degree. At temperature of 25 degrees Celsius. Then, temperature equals 298 Kelvin. Kaya naging 298 Kelvin dahil di ba nga Kelvin, ang temperature of Kelvin ay 273. Kaya pag plinas mo yung 273 Kelvin plus itong 25 degrees Celsius, magiging 298 Kelvin. Then, ito yung formula na ating gagamitin. Ito yung given kanina. Change in enthalpy niya ay positive 177 kilojoules. Ito yun. Minus temperature, ito, 298 Kelvin. Times change in entropy. Ito yung given. Positive 284 joules per Kelvin. Kaya ito yun. Tapos, i-convert natin siya sa 1 kilojoules over 1,000 joules para makancel-cancel. Kasi ang hinahanap ay yung change in free energy. Ang kailangan nating unit ay kilojoules. Then, pag kinumpit natin to, 177 kilojoules minus 298 and 285 times 1 over 1,000 equals positive 92 kilojoules. Then yung temperature nandito. Pwede ring delta G equals positive 92 kilojoules. Then ito. If the change in free energy is positive, it is non-spontaneous. Jadi, ibig sabihin itong unang solve natin ay non-spontaneous. The reaction will not occur at 25 degrees Celsius. Kaya ito namang next natin gagamitin ay itong 500 degrees Celsius. At temperature of 500 degrees Celsius, then yun nga, ipagpa-plus natin yung temperature ng Kelvin na which is 273 plus 500 equals 773 Kelvin. Ito yung ating temperature na gagamitin. Then same ulit, yung ating enthalpy 100 positive 177 kilojoules minus temperature which is 773 Kelvin. Then yun ulit ang ating entropy which is 285 joules per kilo. Kasi yun ulit, i-convert ulit natin siya sa 1 kilojoules over 1,000 joules. Then yun, 177 kilojoules minus 773 times 285 times 1 kilojoules over 1,000 joules. And pag kinompute ulit natin siya, ang magiging sagot ay negative 43 kilojoules. Yan yung ang ating change in free energy. Then ito yung temperature niya ulit. Pwede rin, kahit hindi na natin ito isama, pwedeng delta G equals negative 43 kilojoules. At dahil siya ay negative, siya ay di ba dito kanina, pag positive yung ating change of free energy, yun ay non-spontaneous. Then pag negative naman, siya ay spontaneous. Then ito, the reaction will occur at 500 degrees Celsius and ammonium chloride will decompose to ammonia and hydrogen chloride. At high enough temperature, the entropy change will dominate the enthalpy change term.
So the second law of thermodynamics is very important because it talks about entropy, and as we have discussed, entropy dictates whether or not the process or a reaction is going to be spontaneous. So entropy yung makakapagsabi whether spontaneous or non-spontaneous yung mga nangyayari. So as we have discussed, pag daw spontaneous, it will happen naturally. And if non-spontaneous naman, you will have to put energy to make things occur. It explains that hot objects always cool unless you do something to stop the process. It expresses a fundamental and simple truth about the universe, that disorder, characterized as quantity known as entropy, always increases. So yun nga, you can stop things from occurring if it's naturally happening unless you do something to stop the process or you put some energy to stop the process. So let's take a daily life example. So we drink coffee every day. What happens to our cup of hot coffee in say 10 minutes? Of course, the coffee will cool down. Or in thermodynamic terms, you will tell me that hot coffee gives out heat to the surroundings and in turn, the coffee cools down. You're 100% correct, but the thing you might not have realized is that this very obvious daily life phenomenon governed by entropy. So let's look at the example above. So we have here different scenarios, and the coffee here is at 45 degrees Celsius. So we can say that it's hot. So in scenario 1, 10 joules of heat is absorbed by hot coffee. And let's say the surroundings is at 25 degrees Celsius. So it's much colder than the coffee. So in the scenario 2, 10 joules of heat is given out by the hot coffee. So it means that it cools down because it releases heat. And it explains that it is spontaneous, that it just naturally cools down. We have a sample problem here. So find delta H, delta S, and delta G. Is this reaction exothermic, and is it spontaneous? So here are the given. So we have here nitric oxide, which is a gas. We have here oxygen, which is a gas too. Then it produces nitrogen dioxide, which is also a gas. So here are the number of joules per Kelvin mole to calculate the entropy change. So we have 211 for nitric oxide, and 205 for oxygen, and 240.5 for nitrogen dioxide. Tapos sa baba naman, yung kilojoules per mole to calculate the enthalpy change. So we have 90 for nitric oxide, 0 for oxygen, and 34 for nitrogen dioxide. So let's first calculate the entropy change. So for the entropy change, you just have to subtract the products and the reactants. So first, let's multiply the products, which is the number of mole here. We have 1 for the nitrogen dioxide. Then multiply it to the number of joules per Kelvin mole, which is 240.5. And then we have to subtract it to the reactants. So we have 1 mole for the nitric oxide and 211 joules per Kelvin mole plus 1/2 mole multiplied by 205 joules per Kelvin mole. So the answer is negative 73 joules per Kelvin. So that's for the entropy change. Next, let's calculate the enthalpy change. So we have here 1 mole for the nitrogen dioxide multiplied by 34 kilojoules per mole. Then subtract with the reactants. So we have 1 mole for nitric oxide multiplied by 90 kilojoules per mole plus 1/2 mole for our oxygen multiplied by 0 kilojoules per mole. We have the answer of negative 56 kilojoules for our enthalpy change. Next, let's calculate the Gibbs free energy change from above. So here is our formula for the Gibbs free energy. We have delta G is equals to delta H minus T delta S. So for our enthalpy change, we have the result of 56 kilojoules. Then subtract with our constant temperature of 298 Kelvin multiplied by our result of the entropy change, which is negative 73 joules per Kelvin, and multiplied by 1 kilojoule divided by 1000 joules. If we multiply this, we will get 21.8 kilojoules, and we just have to add it with negative 56 kilojoules, and the result will be negative 34.2 kilojoules for our Gibbs free energy change. So the findings of our calculations are the reaction is exothermic at a delta H, which results with negative. So this means that the heat energy is released from the surroundings, and the potential energy of the product is lower than the reactants. Next, it becomes more ordered, less gas at a delta S, which results with a positive. Next, it is spontaneous at 298 Kelvin at a delta G, which is a negative. So this means that the entropy change increases. That's why it is spontaneous. And that's it. So the next reporter will discuss the chapter summary.
Chapter Summary. Second law of thermodynamics states that the entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. Spontaneous process is a physical or chemical change that occurs by itself. Entropy, or S, is a thermodynamic quantity that is a measure of how spread out or dispersed the energy of a system is among the different possible ways that system can contain energy. And yung formula niya na gagamitin ay change of entropy of the universe equals change of entropy of the system plus change of entropy of the surroundings. Formula for calculating entropy naman ay change of entropy equals summation of n entropy of the products minus summation of m entropy of the reactants. Then calculating the entropy of in the surroundings is change of entropy of the surroundings equals negative change of the enthalpy of the system over temperature. Then lastly is determining the spontaneity of the reaction using Gibbs free energy. Ang formula niya naman ay change of free energy equals change of enthalpy minus temperature times change of entropy. Yun lang po. And